This is a section on topic 8.2 in digits about rate of change. So you should recognize that the rate of change is the slope. So at the top of your notes here, we have notes already given to us. Review that the rate of change is the vertical change over the horizontal change. We have also talked about how that's the change in y's over the change in x's. So if you look at the diagram, the change in y's go up 6, and it goes right 8, so it's 6 over 8, and we always simplify to be 3/4. And the rate of change is a linear function, of a linear function is always constant, so it goes up 3 over 4 every time. If you look at it from this point of view, we would go up 3 and over 4, get another point on the graph, up 3 over 4, get that point on the graph. So it's consistent. Okay, sorry about that interruption from Mr. Mosca. So let's continue on with the example about the platform. So find the rate of change of the linear function that models the height of the zip line. So if you take a look, the rate of change is the slope. So we're going to do change in y's over change in x's. Now I noticed that a lot of students were counting spaces when they were doing the rate of change. We need to make sure that we're looking at the numbers and not the spaces. So the change in the height is down 50 feet, and the change in the length, the horizontal distance, is, if you look down here, that would be 300. So it's 300 feet. So the rate of change is down 50 over 300, and we always simplify our answers. Divide both sides by 10, and we get 5 over 30, negative 5 over 30. That's divisible by 5, so we get negative 1 over 6. So the rate of change is negative 1/6. All right, moving on to the next problem. What's the rate of change of the linear function that models the ramp's height above the road? So if you take a look, here is the ramp right here. So we're going to find the rate of change. So we need to do change in y's over change in x's. So the y's change by going up 1 unit, and the x's change by going over 4 units. So the rate of change is 1 over 4. All right, let's go on to the next page. And on your notes, it's a little hard to see what line we're talking about. What is the rate of change of the linear function that models the top of the truck? So we're actually talking about this line here that's in green on the screen there. It's hard to see it on your notes though, so make sure you know what line we're talking about. So rate of change is the change in y's over the change in x's, but you notice that we have a horizontal line. So the y's don't change, so the change in y's is 0. The change in x's is 6. Well, 0 divided by 6 is 0, and that should make complete sense because rate of change is slope, and we have a horizontal line, so of course you know what's coming. Horizontal has slope of 0. Okay, let's now relate what we have done here to the equation of a line. So rate of change is the vertical change over horizontal. It's what we've been talking about this whole time, change in y's over change in x's. If we look at the rate of change between the 2 points on the line, -1 and 2, 5, we see that there is a change in y's of 6 and a change in x's of 3. So that's the 6 over 3 that we got there. 6 over 3 simplifies to 2. So the rate of change is 2, and we know another word for rate of change is slope. So it goes in the form y equals mx plus b, rate of change is the m. Make sure that you realize the x is not part of a slope. It is the coefficient in front of x that the slope represents. All right, and if you take a look down at this next example, identify the equation of each linear function shown at the right. State the rate of change for each function. So these are our choices, and we have to choose which one matches the graph and the table. the graph is pretty easy. We're going to look for the y-intercept. In this case, it is 3. And the slope, we're going to find the change in y's over the change in x's. So it went down 1.5 and over 1/2. Now where I'm looking here, remember that you have to look at the scale, not the lines. So it was one line, but one line is only half a unit. So the slope is down 1.5 over 1/2. If I choose a different one, I would go from here to here. That might be easier for you. You go down 3 and write 1. So the slope is -3 over 1. And if you look at the equation choices, the only one with a negative slope is that one there. So the equation is y equals -3x plus 3. And the rate of change is my slope, so we put -3. If you put an x there, it would be considered wrong, so make sure you realize that slopes and rates of change do not include the variable x. If you take a look at the table, this point here is significant. That's the point 0, 0, that's the origin. So if I graph it just briefly, I know that my y-intercept is 0. So if you take a look at your equation choices over here, these two are out because the y-intercepts are 3. So now my choice is y equals 1/3 x and y equals 3x. So what we're going to do is we're going to find the rate of change by doing the change in y's. So from 0 to 2/3 it goes up 2/3. Over the change in x's, it goes up 2 for the x's. So it's 2/3 over 2. Now let's review what that means. 2/3 over 2 means 2/3 divided by 2. And to divide by 2, we're going to multiply by its reciprocal, 1/2. And then we get 2 over 6, but I'm going to simplify first, and we get 1 over 3. So my slope is 1 over 3, which means y equals 1/3 x is the correct answer. And then the rate of change, again, is the same as the slope, so it's 1 over 3. Let's move on to the next page. This is the last page of the section. We're talking about an employee at a candle making company, and they collected data about the burn time of a new candle. So, find the rate of change of the candle's height between hour 1 and hour 4, so that's why they are highlighted in the graph, or in the table. What does the rate of change mean in the situation? So you will be asked a lot in this topic about the meaning of the slope. So let's find the slope first. The slope is the change in y's over the change in x's. So we're looking at 22 to 13. So that means it goes down 9 for the change in y's. For the change in x's, it goes from 1 to 4, so that means it goes up 3. So the rate of change, remember, is the change in y's over the change in x's. So that's -9 over 3. And if you simplify that, it's -3. So the rate of change is -3. Now, most importantly is that you realize what the rate of change tells us. We did the height of the candle over the number of hours the candle burns. So what we just figured out is that the height of the candle goes down 3 centimeters every hour. We found the unit rate. So remember that we've already learned that the slope equals the unit rate, and the labels in my table will tell us it goes down centimeters per hour. So this means the candle burns 3 centimeters per hour. And that's what you would put for the meaning of the slope. Let's do the next one there. use the values for a 1 ounce candle and a 5 ounce candle to find the rate of change for the data in this new table. Now, the new table, sorry about that, the units on my new table are different. This is burn time in hours and weight of the candle in ounces. So we're supposed to use the 1 ounce candle and the 5 ounce candle according to the directions. So we're talking about these two values here. So the rate of change is from 5.5 to 27.5. That means it goes up 22. And the weight of the candle from 1 to 5 goes up 4. So we're going to do 22 over 4, which simplifies to 11 over 2. But since we have decimals in the burn time, we're going to go ahead and write 11 over 2 as 5.5. So the rate of change, we could write 11 over 2, or we could write 5.5. It doesn't really matter. So what this means is that it burns 5.5 hours for every ounce of candle we have. So again, the unit rate is hours per ounce. So the rate of change is 5.5 means the candle burns 5.5 hours per ounce that it weighs. Alright, so that sums up the section 8.2, and I have a Google form for you. Here are the questions for the Google form. So I'm going to need to slide it up for you a little bit. Alright, so 1, 2, and 3, you're just asked what the rate of change are for each of those situations. Number 4 asks you to explain what the meaning is for number 3. And then for number 5, you're going to have to explain how to use the table to determine the rate of change. So you're just describing how to find the rate of change in a table. Alright, so this is the bit.ly you need to go to. You need to go to bit.ly/Adesso82 and put the answers to these 5 questions in the Google form.